Okay, good morning. Welcome to
Awesome Math number 19.
Awesome Math number 19. So this problem I picked out as a challenge problem from the section we've been doing where we've been talking about multiples and divisors and least common multiple. How many of the first 100 positive integers are divisible by 5 or 7 but not both? Very interesting question.
Yeah.
Okay, I'm going to hold the Euclidean algorithm pig.
Yep.
All right. I don't think we're going to be doing a Euclidean algorithm on this one.
That's too bad.
That is too bad.
Wow.
Pig is sad.
I guess we can just the multiples of 5 between 0 and 100.
Well, 1 and 100, the first positive, yeah.
So they're 5, 10, 15, all the way up to 95, 100.
Okay, very good. How many of those are there?
Well, we have to figure that out.
Ah, okay.
And now the multiples of 7 are 7, 14, 21, up to 84, 91, 98.
Ooh, okay, awesome. Good start.
So now we have to figure out how many there are. So we just divide for 5, we divide everything by 5.
Okay.
So there's 1, 2, 3, 4, all the way up to 100 is 5 times 20.
Okay.
So 19. And then now we have to divide everything by 7 here. So 1, 2, 3, 4. And then it goes up to 7 times 12 is 84. So 12, 13, and 14.
Okay.
So it looks like there's 24.
All right.
Because we just add them together.
Okay.
So 34.
What does that count?
That counts 1 to 20 and then...
All right, so that counts all the multiples of 5 plus all the multiples of 7. Is that
Yeah.
what we were supposed to be counting?
5 or 7. The first... Yeah, it looks like... Well, it says 5 or 7. But now we have to look through the...
Does the sentence end here?
No, but not both.
Both.
Now we have to see if any of these...
Okay, so we multiples of 5. We have 20 of them. And multiples of 7, we have 14, you said. But the question is, how many are multiples of both?
Well,
And that's why this problem's in this chapter.
the tricky... I think I have a bit of a trick.
Okay.
7 times 5...
Yeah.
7 times 5 is 35 and 7 times 10 is 70. So there's two of them.
There's 2 of them. Okay, so what does that mean we're going to have to do if we're going to have to throw those out, the 2, 35 and 70 that are multiples of both?
That means we're going to have to subtract 2 from the multiples of 7.
Okay, so now we only have
12.
12 that are
Now
not...
now we have to do here the ones that are divisible by 7. So 7 and 14.
Where? Which list are you in?
The multiples of 5. So 5 and 7 is 35. But
Okay.
we already did that one.
Well, we got rid of them on the list from the 7.
So 7 and 14 are the ones we need to cross out.
From what list?
From the multiples of 5.
Okay, here's your multiples of 5. Cross out 7.
Well, but I mean like 7 times 5.
Ah, okay. 7 times 5 is?
35.
All right.
So then 5 times 14. We need to.
Okay, 5 times 14 is?
It's is 75.
5 times 14 is?
So it's 50 and then 70.
70. So we have to cross out 35 and 70 from this list. What did we have to cross out from this list?
35 and 70.
The common multiples, right?
Yeah.
So the same ones on this list, 35 and 70. So how many is that?
That's 18.
18. Aha!
18. So 18 and 12 is so 30.
30. There we go. So when we added them up without thinking about what was together, we got 34. But then we had to cross out the common multiples from both lists.
Yeah.
So we had to cross out 35 and 70. Wah, wah. And we had to cross out 35 and 70 from this list too. Wah, wah. So how many numbers did we have to cross out?
4.
But how many common multiples were there?
There were 2.
There were only 2. So we had to cross it out. We had to cross out those 2 twice from both lists. So we got 30. Good job. That's a tricky problem. That's a counting problem, a least common multiple problem. Oh, where did least common multiple come in?
At the end.
How? Where?
In the least common multiples.
35 and 70. Sneaky, right?
Yeah.
All right. There's the pig, who's very happy about that problem. Good job.